service. Atmospheric circulation. We saw this already. Gradient is slope, gentle gradient slope, steep gradient fast. Second force that is responsible is frictional force, right? So first, vertically if I take till 3 kilometers, we call it as frictional layer. Okay, till 3 kilometers it is called as frictional layer. Greater than 3 kilometers, it is called as non-frictional layer. Okay, so vertically atmosphere is divided into two. 3 kilometers frictional, greater than 3. That means in statement wise what they will ask, with height friction decreases. Okay, with height friction decreases. Second, horizontally if I take northern hemisphere will have more friction, southern hemisphere will have less friction. Why? Land is more in the northern hemisphere, water is more in the southern hemisphere. I told you, northern and southern, any question point is what? Land and water distribution. Okay, next. Gravitational force. Because of gravitational force, cold air descends, right? Very important. Last 2 years they have started asking Coriolis force. What are all the factors that comes on Coriolis force? See, don't get into the logics at this point. Just recollect what are all important. That's it. Okay. First one. It is not a force, but just an effect. What is the reason? No. Why is it not a force? Just an effect. Because speed is not changed. Only direction is changed. Due to Coriolis force, what is going to happen? Right in the northern hemisphere, left in the southern hemisphere. So we say what has changed? Direction, not speed. Okay. So statement 1, statement 2. Okay. Speed doesn't change. Direction changes. Second, it's true. Coriolis effect is due to rotation of the earth. right in the northern hemisphere, left in the southern hemisphere. This is always. Okay. Clockwise in northern hemisphere, anti-clockwise in southern hemisphere, mostly, not always. If you recollect, within cyclone, circulation will be anti-clockwise in the northern hemisphere, clockwise in the southern hemisphere. So that is mostly. Understand that always is wrong. Cyclone, because it's moving inward. Inward movement will be different from outward movement. But both cases it turns right only. When we see, both cases it turns right only. But it's inward movement and it's all about how it appears. I showed you, just see this. It moves from west to east. What is this? Anti-clockwise. Correct? Anti-clockwise. You see here, west to east. What is this? Clockwise. Same one. See from here. It is anti-clockwise. I'm not changing. You see, this became what? Clockwise, anti-clockwise. Perception. That's why these two become perception. This is actual direction. Right and left is actual direction. This is perception. Okay. So, guys, geoid shape of the earth. Okay. What is the meaning of geoid shape of the earth? Bulge near the equator, flat near poles. As it is bulged near equator, Coriolis force is 0. Okay. Why Coriolis force is 0 near equator? Because of geoid shape of the earth or bulged near the equator. Latitudes have same length. Okay. Then what is the problem here? Here you will have. So Coriolis force is directly proportional to latitudes. Coriolis force is 0 near 0. 90 degree means maximum. 0 to maximum. Then yes. What is the reason? See here. Now, Russia, can we say latitude length is less? Russia, latitude length is less. Equator latitude length is more. Correct? Russia length is less. Equator is more. That means, can I say a place near equator takes or covers more distance? A place near poles cover less distance, but both takes 24 hours. Do you agree? Earth's rotation is how much? 24. Near equator more area, 24 hours. Near poles less area, 24 hours. Now what is going to happen? Now you see, from Russia, when a missile is trying to come, right? Missile is coming straight. If Earth is not rotating, it will come and fall. But if Earth is rotating, what is going to happen? It will not fall at the same place. It will go and fall at different place. This is Coriolis effect. What exactly is Coriolis effect? Russia is slow. Equator is fast. Right? So why is this difference? Because latitude length of poles is less. Latitude length of equator is more. So Russia will be moving slowly. Less area, 24 hours. More area, 24 hours. Equator must be moving faster. So when I go from slow to fast, what is going to happen? Deflection occurs. Now you take the case of here, equator. Can I say both the latitudes will have same length? Same length? Same length means, can we say same speed? And if both are moving at same speed, if we try to throw anything, can we say it goes straight? That's why there is no deflection. Okay, imagine if Earth is not rotating, what is going to happen? It will go straight. It will not change the direction. That's why Coriolis effect is due to rotation of the Earth. And why rotation is problem? Rotation is not a problem if it was like, what you call it as a cylinder. Rotation is a problem because it is spherical. In a spherical object, what is the problem? Different latitudes are of different lengths. If length is more, 24 hours, it has to cover more area. If length is less, 24 hours, it has to cover less area. Due to this, different places are moving at different speeds. We call angular velocity in other terms. Near equator, all places are moving at the same speed. Because of this, we say it is 0. Okay, next. Gravitational force is actually pulling, right? This is because of, as I showed, it is clearly because of latitudinal variation. Okay, you are trying to say as it is less here, gravitational force is less here, Coriolis effect will be less. No. Did you understand the logic that I told? Coriolis effect, basic concept of Coriolis effect is what? It is trying to change the direction. Why is the direction changing? Because different latitudes are moving at different speeds. Okay, you just take this case. These are moving at 80 km per hour. This is moving at 100 km per hour. I want to throw something from here to here. By the time A throws, can I say this will move? Rather than going straight, it goes and hits here. That means, can we say direction changed? If both are moving at 80 km, it will go straight. If this is at 100, this is at 80, it will go this side. Okay. So, as I'm trying to say, words are very, very important. Coriolis effect is because of rotation of the Earth. Why? Earth is in spherical form, that is geoid shape. Because of this, different latitudes are moving at different speeds. And as they move at different speeds, when you move from slow to fast, deflection will be there. When you move from fast to slow, deflection will be there. When there is no change in the speed, what is going to happen? It will go straight. Near equator, because of bulge shape, what has happened? Latitudes are of same length. That means speed is same. As speed is same, they go straight. That's why Coriolis effect is 0 near equator. Near the poles, maximum will be there. That is the reason they go at 90 degrees. Okay. Next point. Yes, you write below. Coriolis effect. Coriolis effect will be perpendicular to pressure gradient force. You see here, if I am high pressure, you are low pressure. Wind is moving from where to where? High pressure to low pressure. Coriolis force will be acting in perpendicular direction. That means it will try to pull like this. Pressure gradient is pulling like this. Coriolis force is pulling like this. So because of this, the resultant force will be here. Okay, this is high pressure to low pressure. Coriolis effect is this side. So in between it will start going. One is pulling this side, another one is pulling this side. It will go like this. So this particular one will be resultant force. Now if I am in northern hemisphere, the pull is towards right. If I am in southern hemisphere, the pull is towards left. See, I'm telling you, we have 4 forces responsible for movement. So nowhere we are telling that Coriolis force is due to gravitational force of the earth. We always say Coriolis force is due to rotation of the earth, correct? Yes, Coriolis force is always due to rotation of the earth. No, the logic of Coriolis force itself is this. You tell me, is there any relation between gravitational force and frictional force? Is there any relation between pressure gradient, high pressure, low pressure, and gravitational force? They are all independent, right? This is also independent. Somewhere, see, I understand somewhere, many people, they don't actually know what is Coriolis effect. So what they do, you're right, they would have connected it with gravitational force, because gravitational force is minimum near equator and maximum near poles. So they might have linked it with Coriolis force also, that Coriolis force is 0 near equator and maximum near poles because gravitational force is minimum, and that. See, that's not actually correct. Second thing, one problem with this field is all faculties are students. Okay, all faculties are students. So it's not that they have studied the concepts. They would have tried to derive certain concepts on their own. Okay, so the simple logic of Coriolis effect is, if at all it is a cylinder like this, you see, Abhiram IAS, A and S, can I say both are same length? If both are same length, now what is going to happen? Whenever we are trying to move, both will be moving at the same speed. Because of that, there is no deflection. If they are moving at different speeds, there will be deflection. So that is the reason I am telling, it is purely because of rotation of the earth. Okay, so UPSC will not go into the depth of Coriolis effect. They will ask you why. Last time question was what? Coriolis force is 0 near equator, maximum near poles. This was the question. If they give statement wise, just remember it is because of bulge shape of the earth or geoid shape of the earth. Latitudes are almost same near equator. It varies after that. Okay, so you got this perpendicular? Yes. Then last one, you write Coriolis effect. Coriolis effect is observed on all the moving objects, If the moving objects are faster then Coriolis effect will be more. Underline this word, guys. What is the meaning of moving object? Let us say a missile is going at a very high speed. Deflection is high. Aeroplane is moving at a very high speed. Deflection will be high. Wind is moving at a very high speed. Deflection will be more. You recollect steep gradient, gentle gradient. Steep gradient, can we say wind speed is more? Coriolis effect will also be more. Okay, there brackets you write, brackets. In steep gradient, wind speed will be high. Wind speed will be high. So Coriolis effect is high. Fine? Yes. Not latitudes, but it is about the wind speed or missile speed. Okay. This Coriolis effect is very, very important. Okay. Now, yesterday I showed you two types of pressures. Low pressure, high pressure. Thermally induced, dynamically induced. Thermally induced low pressure, dynamically induced low pressure. Thermally induced high pressure, dynamically induced high pressure. Now, based on this logic, please see, they won't ask this for prelims, but in case of any other question, can you tell me where will you have high temperature, where will you have low temperature? High temperature near equator, near poles, low temperature. Guys, can we call this as differential heating of the earth? Is earth heated same or is there differential heating? So remember, differential heating of earth is responsible for circulation. Okay, circulation is because of differential heating of the earth. Now you tell, because of differential heating, we get Hadley cell, ferrule cell, polar cell. From Hadley cell, ferrule cell and polar cell, jet streams come. So jet streams are also due to what? Differential heating of the earth. Okay, so differential heating of earth is primary reason for atmospheric circulation. Now you tell me land and water. Can I say land gets heated more compared to water? That is also differential heating of the land and water. So whenever sun comes into picture, sun is not heating everything in the same way. It is heating differently. That difference is leading to these issues. Okay, so now, can you tell me what is going to happen? Low temperature, yesterday if you recollect, low temperature, air will also become cooler. Cold air comes down. So what is the meaning of that? There will be descending and diverging. Can you try here? Converging and rising. Till where does it rise? Rises till tropopause. Why only till tropopause? Because in stratosphere there is no vertical movement of air. You recollect, I told you there is no vertical movement of air. This is the reason all the clouds also spread horizontally. So one branch will go like this, another branch will go like this. Everyone? Now the branch which is going like this, can I say at this height it will become cooler? What is the temperature? -65. It became cooler. And second, will it go straight? Will Coriolis effect allow it to go straight? No. Either it will turn to the right or it will turn to the left. That means from equator it cannot go to the poles because of Coriolis effect. Right? And as it cannot go to the poles, it is becoming cooler and heavier and it will start descending. Can you tell me, is air descending because of Earth's surface temperature or is air descending because air has become cooler? Air has become cooler. As air becomes cooler and descends, it is basically called as dynamically induced high pressure. Yesterday's class you see, Yesterday's topic, you see, high pressure, you see. I gave you two types of high pressure. Dynamically induced high pressure. What is dynamically induced high pressure? Whenever air becomes cooler and if air comes down, it will be called as dynamically induced. It comes and hits, one branch comes this side. Now again this circulates. What is this called as? Hadley Cell. Imagine if Coriolis force was not there. If Coriolis force was not there, air from here would have gone till here. It would have circulated. That is unicellular circulation. This is tricellular. Okay, so what is the reason for coming down? Gravitational force. What is the reason for not reaching the poles? Coriolis force. After hitting, another branch will start going like this. Now you tell me, wherever warm and cold meets, which air rises? Warm air rises. And you recollect, whenever warm air rises, I want you to recollect, wherever cold and warm hits, warm air rises. This is called dynamically induced low pressure. Yesterday we saw two types of low pressure. You see now? Yeah, just a minute. What is this cell called? Ferrel cell. What is this? Polar cell. Can you give the names for each one? Which is high pressure, which is low pressure? Yes. What is high pressure? You tell me. I told you. Don't relate it with temperature. Two words I told. Low pressure means two words. High pressure means two words. More particles, high pressure. Less particles, low pressure. But what is the word? Can we say converging and rising is what? Low pressure. Descending and diverging is what? High pressure. Can you tell me what is happening here? Converging and rising. Yes. This is low pressure. Can I call it convergence zone? Why is it converging? Can you tell me, guys? Why is it converging? Because Earth's surface temperature is hot. Correct. Why is Earth's surface temperature hot? Can I say sun's rays is heating Earth? That is the reason. Correct. But sun's rays is not straight over equator throughout the year. It will be from Tropic of Cancer to Tropic of Capricorn. Do you agree? Yes. Sun's rays will be vertical from where to where? Tropic of Cancer to Tropic of Capricorn. You remember March 21st it will be on equator. June 21st it will be on Tropic of Cancer. September 22nd it will be on equator. December 22nd it will be on Tropic of Capricorn. That means it will be vertical in between Tropic of Cancer to Tropic of Capricorn. So, as it is in between Tropic of Cancer to Tropic of Capricorn, it is called intertropical convergence zone. What is it called as? Intertropical convergence zone. Can you tell me why is it called intertropical convergence zone? What are the characteristics which leads to it? One, it is a low pressure area. What is the meaning of a low pressure area? Converging and rising. That's why it's called as what? Convergence zone. Second point is what? It is because of sun's temperature. And sun's temperature is, sun's rays is not same throughout the year. It will be in between Tropic of Cancer to Tropic of Capricorn. That is the reason it is called as intertropical. And as it is associated with Earth's surface temperature, we call it thermally induced. What type of low pressure it is? Thermally induced. Okay. Now you try this one, guys. Is it converging and rising or descending and diverging? The moment I call it descending and diverging, it is what? High pressure. And this area is subtropical high pressure. Can I say here, air is coming down because air became cold. What is this called? This is dynamically induced. What is this? This is thermally induced low pressure. Guys, please see here and tell what is happening in this particular place. Converging and rising. What is converging and rising? Converging and rising is low pressure. As it is in subpolar region, it is called as subpolar low pressure. And I told you, it is not rising because of Earth's surface temperature, but it is rising because of mixing of warm and cold air. So, what type of pressure is this? Dynamically induced. Yes. What is this here? This is polar high pressure. Some people tell it is coming down because air is cooler. Some people tell it is coming down because land is cooler. So it is considered both thermally and dynamically. Okay. Can you tell, is this horizontal movement of air? Horizontal movement of air is called wind. Wind. This wind is polar easterlies. This wind is westerlies. These winds are trade winds. Hadley Cell surface winds are trade winds. Ferrel Cell surface winds are westerlies. Polar Cell surface winds are polar easterlies. Have you heard these words? Yes. If you want to draw, take time, draw properly. It moves from east to west. But which one? No part. What are winds? Rising is what? Vertical. We are talking about horizontal. So I'm talking about this. Horizontal movement is wind. Vertical movement is air. So whatever we are talking is only about this line, horizontal movement. Okay. Why is it easterly? Why do you call it easterly? East to west. East to west. So wherever the wind starts, we give name of that particular thing. Polar easterlies. Westerlies is west to east. Trade winds, northeast to southwest, southeast to northwest. I'll show that. Okay. Done? Yes, sir. I'll give that circle. Circle I'll give. What I gave you is, have you heard of these winds? These are planetary winds. Yes. They are in between what? Between subtropical high pressure and ITCZ you observe trade winds. Between subtropical high pressure and subpolar low pressure you observe westerlies. Between polar high pressure and subpolar low pressure you observe polar easterlies. These are surface winds. See this one I'm talking. Now, some words, guys. ITCZ is thermally induced. Second point. Guys, what determines Earth's surface temperature? Guys? Can I say Earth's surface temperature is because of sun's rays? It is also because of land and water distribution. Can I say if land is there, it gets heated soon compared to water bodies? So for me, Earth's surface has to become hot. Earth's surface becoming hot means what? Land or water, it should become hot. So now you tell, where do you have more land? Northern hemisphere or southern hemisphere? So ITCZ shifts more in the northern hemisphere compared to southern hemisphere. Why? Because land and water distribution comes into picture. So because of this, you tell me what is going to happen? ITCZ shifts more in northern hemisphere and ITCZ is almost absent in South Atlantic Ocean and Southeast Pacific Ocean. Okay, this is the reason cyclones are not there in South Atlantic and Southeast Pacific. No, it shifts a bit. Africa, Australia and all, there it shifts a bit. It's all about distribution of land and water. That's why we use the word almost. Okay, then guys, you see here, solar insolation is one, land and water is one. ITCZ is helpful for what? Cyclones. Why? Cyclones are mostly associated with high temperature, low pressure. Okay, so as ITCZ is more in which hemisphere? Northern hemisphere. More cyclones in northern hemisphere. Okay. See, actually, cyclones want water. Tropical cyclones want water. Southern hemisphere has more oceans. If southern hemisphere has more oceans, they should have more cyclones. Correct? But cyclones are not much in southern hemisphere. It's more in the northern hemisphere because of ITCZ. That's why factors become important. Okay. You might have heard hurricanes. North America hurricanes. North Indian Ocean cyclones. North Pacific Ocean typhoons. Southern we have only Willy Willy in Australia. Why only less in southern hemisphere? Because ITCZ doesn't shift much. Okay. This word is important. Next, shall I move? Guys, 5 degree to 5 degree. What happens to ITCZ? It starts rising like this. Will you have less air or more air? ITCZ. If all air rises, you will have less air. Less air is called region of calm. Region of calm is called doldrums. Okay. Air sound is also not visible. Where are doldrums? Doldrums are within ITCZ. When ITCZ is near equator, we will have doldrums. Okay. Will you have zero air or less air? Less air. Now, in this region, the less air will blow from west to east. So it is called as equatorial westerlies. Within ITCZ, near equator, the wind will blow from west to east, so it is called as equatorial westerlies. ITCZ is very important, guys. Last point. You write this. In North Indian Ocean, as land is more, ITCZ shifts till 35 degree north. ITCZ itself means what? Intertropical. It should be in between 23.5 to 23.5. But it is shifting till what? 35 degree. Tibet. Why is it shifting till Tibet? Because of land. This basics of climatology is this much only. What? Because of high temperature, there will be low pressure. Because of low temperature, there will be high pressure. Why you will have high temperature? Because of sun's rays. Or because of land and water. If land is more high temperature, water is more low temperature. Answer for you will be somewhere within this only. These words only. If you can look for that, it's enough. Don't think beyond that. Okay. These keywords, if you can understand, that's enough. You understand? You tell me which ocean has land surrounding it. North Indian Ocean. Can we say South Indian Ocean? Water is there. Atlantic Ocean, water is there. Pacific Ocean, water is there. North Indian Ocean, what is going to happen? India comes. And the worst part is, India is within Tropic of Cancer. So what is going to happen? ITCZ shifts easily. Okay. So, did you get this? Now, what is the second one? You will have subtropical high pressure. What is subtropical high pressure? Descending and diverging. One side you will have Hadley Cell, another side you will have Ferrel Cell. Here you had cold air. As I told you, it is dynamically induced. They also call it as horse latitudes. Subpolar low pressure. Yes, one side cold air will be there, another side hot air will be there, one side ferrule cell will be there, another side polar cell will be there. Wherever warm and cold meets, we call it as fronts. So it is frontal zone. Right? And if you have fronts, there is possibility of temperate cyclone. ITCZ is associated with tropical cyclone. Fronts are associated with temperate cyclones. Okay. Here, just a minute. You see here, ITCZ is associated with, like, evergreen forest, and it will be mostly hardwood. Amazon, Congo, they are all associated with this ITCZ. Hardwood evergreen forest. Yes, this frontal zones They are associated with softwood evergreen forest. These are associated with tropical deserts. Subtropical high pressure associated with deserts. Sahara Desert and all. Then poles, low temperature, descending and diverging. This is polar high pressure. It leads to which climate? Tundra climate. Shall I? Yes. You will have ITCZ 5 degree north to 5 degrees south. Winds will go in this direction. What is it called as? Equatorial westerlies. Okay, and then subtropical high pressure 25 degree to 35 degree. (55 degree to 65 degree). Subpolar low pressure. Polar high pressure. Wind always blow from high pressure to low pressure. See here. High pressure to low pressure. High pressure to low pressure. High pressure to low pressure. Because of this, right in the northern hemisphere, right in the northern hemisphere, right in the northern hemisphere. Here it is curved because Coriolis effect is less. Here it is almost perpendicular because Coriolis effect is more. Okay, these are moving from northeast to southwest. So it is called as what? Northeast trade winds. These are moving from west to east. So it is called as what? Westerlies. These are moving from east to west. So what is it called as? Polar easterlies. Okay, what are the three words you call? What is this cell? Hadley cell, Ferrel cell, polar cell. This is what I showed you there at the bottom. (25 degrees south to 35 degrees south). subtropical high pressure, polar low pressure. Try now. Wind always blow from where to where? High pressure to low pressure, high pressure to low pressure, high pressure to low pressure. Now, this is left in the southern hemisphere. This is left from opposite direction. Left. What is this? Southeast trade winds, westerlies, polar easterlies. This is Hadley Cell, Ferrel Cell, Polar Cell. Trade winds. These are surface winds of which cell? Hadley cell. It blows from subtropical high pressure towards ITCZ. Everyone? Towards ITCZ. It is northeast trade winds in northern hemisphere, southeast trade winds, southern hemisphere. Westerlies. They mostly blow from west to east, surface winds of Ferrel Cell. From subtropical high pressure to subpolar low pressure. Once UPSC asked, westerlies blow from 30° north to 60° south. From where to where it goes? 30 to 60. 30° north to 60° north, or 30° south to 60° south. It doesn't blow from 30 north to 60 south. You see, what is the meaning of 30 north to 60 south? That means from here to here. Don't think typing error will be there. From here to here. This is the reason I am telling you, number wrong. In geography, numerical number will be wrong. Not in other subjects. Don't apply same logic to other subjects. In geography, this is the most important case. Rather than giving $100 billion, developed countries give $100 billion to developing countries. They told developing countries give $1,000, $1,000 billion. No one will give $1,000 billion. Okay, I told you number they will change. Cyclone is having I. I is 10 degrees Celsius. Like lower than the surrounding they gave. Actually, it will be higher than the surrounding. The moment as I'm trying to tell number. Okay, if you are trying to say yes, read statement multiple times. Only after you are very, very confident, then you go with it. Okay, so you get this, guys. Where to where it is going? 30 degree to 60 degree. Okay, now in the southern hemisphere, land decreases. If land decreases, speed increases. Now, prelims question. Why westerlies are faster in southern hemisphere? Westerlies are faster in southern hemisphere because land is less, oceans are more. Okay, and 30 to 40. Equator. See here, 30, 60. Land is more in the northern hemisphere. Southern hemisphere, 30, 60. What is more? Oceans are more. Again, 30 to 40, some land will be there. You see, Africa is there, South America is there, Australia is there. Only South America, little bit of New Zealand. Below that, that also won't be there. That means, can I say, as I keep going down, land reduces. So, what is it called as? Roaring 40s, furious 50s, shrieking 60s. Which hemisphere? Southern hemisphere. Winds, yes. Primary or planetary, which are the three things that you will get here? Trade winds, westerlies, polar easterlies. Secondary winds or seasonal winds. Okay, secondary winds are seasonal winds. Which season do they normally appear? Summer season. Why? Because of revolution. The moment season comes, what comes into picture? Revolution of Earth in tilted axis. Do you agree? Because of revolution of Earth in tilted axis, seasons will come. Okay. Now, whenever you have this, what is going to shift? ITCZ shifts. Why is ITCZ shifting? Because insolation is different. Why is insolation different? Because of tilt of the Earth. Everything comes back to the same point. Okay. So, No need to draw this. If you can just understand, that's enough. Understand it. 0, 30, 60, 90. 30, 60, 90. Tell me which pressure cells you will have. That's it. Okay. 0. What do you have? ITCZ. Below ITCZ, what will come? Subtropical high pressure. Below that, what will come? Subpolar low pressure. Below that, what will come? Polar high pressure. In between these two, which cell will come? Polar cell. Here, which cell will come? Ferrule cell. Here, which cell will come? Hadley cell. Can you name this now? ITCZ. What will be this? Subtropical high pressure. What is this? Subpolar low pressure. What is this? Polar high pressure. Good. Now, what is this called? This is Hadley cell, ferrule cell, polar cell. What are these winds called? Polar easterlies. What are these winds called? Westerlies. Good. Now, which are trade winds? North, east trade winds. Okay. What will you see here, guys? Polar easterlies, westerlies, southeast trade winds. Are you getting the point? We saw 3. Now, this is during equinox. Equinox is March and September. You will have this particular phenomenon. Now, in the month of June, what is going to happen? ITCZ shifts. Can you tell me where will be ITCZ? Yes. So, what is the latitude? 23.5 degree north. Yes. What has shifted? ITCZ. Everyone, 2 minutes, see this carefully. If ITCZ shifts, everything shifts above. So, ITCZ shifted. This went to 45 degree north. This went to 65 degree north. This is 90 degree north itself. Can you try here? ITCZ. What is this called? Subtropical high pressure. What is this called? Subpolar low pressure. What is this called? Polar high pressure. Can I call it polar cell? Ferrule cell? Hadley cell. This is called as polar easterlies. This is called as westerlies. These are called as northeast trade winds. Okay. So here you see now, this is 90 degrees south. Everything shifts above. This will be subpolar low pressure, subtropical high pressure. Everyone? Polar high pressure. What are these winds? Polar easterlies. What is this? Westerlies. Everyone. Wind will move from where to where? High pressure to low pressure. Where do you have highest pressure? Near subtropical high pressure. Where do you have lowest pressure? Near ITCZ. Okay. And near equator, it will be in between. Near equator, it will be in between. Now you tell, 900 is high pressure compared to 800. 900 is low pressure compared to 1000. Right? So because of this, wind will blow from where to where? High pressure to low pressure. First, it will go from 20 degree to equator. From equator, it will go to 23.5. Everyone see here? Can you try? Due to Coriolis effect, it turns to the left in the southern hemisphere. What do we call it as? South-east trade winds. After crossing, it turns to the right. What is it called as? Southwest trade winds. Okay, so compare this with this. Which is the new wind appearing? Southwest trade winds. Which hemisphere? Northern hemisphere. Okay. Which month are we talking? June 21st. Northern hemisphere. What will you have? Summer. Southern hemisphere will have winter. Okay. There. You write a word. Seasonal winds. You wrote summer. Southwest trade winds. Southwest trade winds appear during summer season. During summer season in northern hemisphere. In northern hemisphere, where the winds blow from. Where the winds blow from equator towards Tropic of Cancer. Tropic of Cancer. Below this, they blow from southwest to northeast. Southwest to northeast. Full stop. It is predominant in North Indian Ocean. Predominant in North Indian Ocean as land is more. ITCZ shifts more only in North Indian Ocean. That's why monsoons are there only in India. Okay. Other areas it's less. Done? No need to draw. Just I want you to remember only that particular part. What is the part? Southwest trade winds appear during summer solstice. Where do you see? Northern hemisphere. Next. No, horse latitudes is pushed, not replaced. No cell is destroyed. Areas are changed. Okay? Because 7 is there, you see, all cells are there, 6 cells are there. Guess what is going to happen? What is the alternative now? December 22nd. ITCZ shifts 23.5 degrees south. If ITCZ shifts, everything shifts. No need of everything. Only here you see. This is 1000 now. Wind will blow from where to where? High pressure to low pressure. Yes, you see, right in the northern hemisphere, this is right. Left in the southern hemisphere. Right and left. So, what are these winds called? Northeast trade winds. What are these called? Northwest trade winds. Where are these winds present? It is December 22nd. Southern hemisphere will have summer. Okay, so you can write line below. During winter solstice, or summer in southern hemisphere, northwest trade winds is observed in southern hemisphere, which blows from equator till Tropic of Capricorn. Here, just one line you write. Guys, can you tell me here which winds will be there? Westerlies. What is the latitude of this? Okay, you write below. Note. During winter, in northern hemisphere, STHP, you can write subtropical high pressure, STHP is present near Madhya Pradesh. Full stop. Below Madhya Pradesh. Guess which winds are there below Madhya Pradesh? Northeast trade winds. Below Madhya Pradesh, there are northeast trade winds, and above Madhya Pradesh, there will be westerlies. Okay, you might have heard western cyclonic disturbances. Where is it present? Mediterranean Sea. It is pushed towards India. Which winds will push? Westerlies. Punjab is on the western side, Delhi is on the eastern side. Westerlies pushes dust particles towards Delhi. If there were northeast trade winds, it would have pushed towards Islamabad. Pakistan would have suffered. Okay, winter is the problem. Fine. So, in winter, India has two winds. Which are the two winds? Northeast trade winds below Madhya Pradesh, westerlies above. During monsoons, India has southwest trade winds. Retreating monsoons, India is completely covered with northeast trade winds. That's why winds are important. Okay. Last, you write local winds. Hyphen. Due to local pressure difference, if there is wind circulation, then it is local winds. Example, sea breeze, land breeze, mountain breeze, valley breeze. Below write note. Just remember this, it's enough. Sirocco is a local wind in Europe which blows from Africa. It is called blood rain. Sirocco, Europe or Africa, it is blood rain. Harmattan is in Africa. It is hot and dry winds. It is known as doctor winds. Match the following if they ask you. You must be aware. Name continent, hot or cold. Right? First is also hot. This is also hot. Chinook is in North America. It is hot wind. It is called snow eater. Same Chinook is known as Fawn in Europe. It is also hot wind and snow eater. Blizzard and Mistral. Blizzard is in North America. Mistral is in Europe. Both are cold. Hot. Going from Sahara Desert. Then Santa Ana. Santa Valley in North America. Hot, and it leads to forest fires. Loo in India. Hot and dry winds. Northwestern India, North India. Tomorrow bring plain world maps. Ocean currents we'll see, and then we'll see the associated aspects. Okay, one question mandatorily you will have on ocean currents. After ocean currents, we'll see world climate. So world climate, one question will come. Ocean currents, one question will come. In today's class, may or may not be there. Questions may or may not be there. Atmosphere temperature is important. Winds and all, as I told, westerlies go from where to where. They make those mistakes. Okay, have a glance of this chapter. But first two, atmosphere temperature, go in detail. Okay, so tomorrow ocean currents, mandatorily you will get question, right? But we need to know many aspects. So bring that, we'll practice at least 2 papers, right?